And again, let me quote from your blog. Quote, my job will be think about the theoretical foundations of AI safety and alignment. What, if anything, can computational complexity contribute to a principal understanding of how to get an AI to do what we want to do and not do what we don't want? Yes, I don't know the answer either. That's why I've got a whole year to try to figure it out. And you wrote it on June 2022. And now this is February 2023. Yes. And I think I gave you enough time. What do you know?
What do I know? So, all right. So just to step back, I have known for 15 years or more, people who have been obsessed with AI alignment, who, in fact, who would tell me, you're wasting your life, thinking about quantum computing and P versus NP. The only thing that matters is that AI is going to become super intelligent at some point.
I just emailed Eliezer Yudkowsky the other day.
Eliezer, of course, is sort of, the intellectual leader of this movement. Has been for 20 years, I would say, right? And I was always, I interacted with these people. I sort of maybe enjoyed speculating about it, but there was always a part of me that said, okay, suppose I even agree that this is possible, that eventually AI could become more intelligent. It could surpass us as much as we surpass the chimpanzees or whatever. What do you want me to do about that? Right? I mean, it just seems so far off that there's very little useful that we can say about it today. We can sit around and speculate, right? But in order to make progress in science, usually you need one of two things, right? You either need experiments, or you need a
solid theory.
Right.
Or solid mathematical theory.
Or you need like a clear mathematical theory. And in quantum computing, we're just getting the large scale experiments today, but at least for 20 or 30 years, we've had the mathematical theory. Right. With AI safety, it seemed to me that we had neither. Right. And so,
in a recent, just a second,
all just a priori arguments. Yeah. But then, over the past, certainly over the past decade, of course, being a computer scientist, I notice that deep learning is doing more and more things that people confidently said, would not be done for decades, if ever. Right. And I've never been, I have friends who, when they've seen all of the successes in the last decade that have come just from scaling deep learning, their instinct is to just invent reasons why none of it counts, right? And my attitude has been, no, we don't get to do that, unless you predicted in advance that this would not be done, right? Or that this would be done. Then you don't get to now that it is done, whether it's Google Translate or it's recognizing faces or it's speech synthesis or speech recognition.
ChatGPT,
beating the human world champion at Go. Yeah, and we're not even at GPT yet, right? And then come the large language models, right? Which can write a poem on any topic that you want in any style that you want, right?
Not a poem, a good poem.
Yeah, pretty good.
A good poem.
It's
a decent poem.
That's right. That's right. No, I think often the poems are I think much better than I could have written. Right.
There is a huge debate in my computer science department whether to allow students to utilize ChatGPT, because you can say, write me a Python program that compute Dijkstra, including unit testing, including variable names that my teacher will not notice, and it does so most of the times with no errors. So it is a very powerful tool. And the head of the literature department at Tel Aviv University said about ChatGPT in English, because that it is much worse than the COVID pandemic. This is going to transform education. And this is just ChatGPT 3, not 4. We are way before 4. So many people who tried this massive, incredible machine said, wow.
Yeah.
Wow.
Yeah.
And you said, just a second, you said that all the common sense problems that now we face, all the problems that ChatGPT 2 couldn't do, ChatGPT 3 can, etc. I had Gary Marcus on the show, and he likes, you know, to interfere.
By the way, I would not say all, you know, but yeah, but like for each GPT, you know, a large fraction of all the examples that Gary Marcus will trumpet that it can't do, you know, the next GPT, you got to try it on the next one, and a large fraction of those it will get them. You know, this has been our experience so far.
Yes,
so,
this is amazing.
I don't, you know, I don't have, you know, Gary Marcus's instinct to just, you know, just look for some example where it fails and therefore say that this is not going to, you know, this is not an enormous deal, right? I think it is an enormous deal.
No, it is an enormous deal. And even if you go for,
so as soon as I saw, you know, GPT, you know, a couple of years ago. But you know, then what happened was that someone, you know, on my blog was asking, okay, like what would it take to get you to, you know, work on AI alignment instead of quantum computing? And I said, you know, how much money or whatever? And I said, you know, it's not about the money. It's, you know, it's just, is there a concrete problem that I can work on? And anyway, you know, it turns out that people from OpenAI were reading my blog. And so then they emailed me and they were like, well, would you, you know, take a year off and work with us? And I was, you know, at first I thought it was almost like a joke. It was like, you know, why do you want me? I'm a, you know, quantum computing, computational complexity theorist. Like, what do I know about AI safety, right? But, you know, they talked me into it. And so it's been an extremely interesting year. And so to come to, you know, your question of, you know, what do I now know about AI safety, right? Well, I mean, I think they're sort of the big questions of, you know, what do you do once an AI becomes, you know, more capable than a human across just about every domain. And, you know,
but this is the alignment problem, and this is not the AI ethics.
That's right. What's the continuing role for humans in that world, right? And people, you know, continue to argue about those things. And, you know, I'm not even sure, you know, how much useful I have learned or could say about them. But I think that what is new in the past couple of years is that we now have these very powerful systems, like such as GPT, right, that are out there, you know, that are starting to change the world. Okay, and you know, they're not maybe, you know, truly human level AIs, okay, but they you know, they're a different kind of intelligence than our kind of intelligence, okay, but you know, they're clearly incredibly powerful, and they're clearly powerful enough that they already raise, you know, all sorts of societal issues.
Okay, so now with your permission, can I start with the hard questions?
Yeah, all right.
Okay.
I mean, I was going to talk about ChatGPT.
No, because the hard question is about ChatGPT. Now, let's start with AI safety. AI safety, many people say that AI safety is basically, you know, the idea of gender and bias, offensive answers regarding gender and race. Would you say it basically this is
so there is a sort of spectrum in the AI safety field, right? Between, like, on the one end, the AI ethics people who are
AI ethics. Okay. So let's start with
the
AI
ethics. People are, I would say, are mostly concerned about issues of bias and fairness and things like that.
Okay,
And
so
then
let's
on
start.
the other,
Let's
and then
start
on the
with,
other extreme, there's the AI alignment people
okay.
who are mostly worried about AI destroying the world.
Okay, so
Right?
with your permission,
And
let's start
these
with
two groups do not see eye to eye at all, right?
left wing versus libertarian.
That is part of it. Yeah, that feeds
Okay,
into it.
let me start with AI ethics because I think it's very important. I wrote a book about IQ in Israel. IQ is the unpleasant truth, and I had on my show all the biggest name in IQ research in the world. And let me just quote Thomas Sowell, which is a great thinker, about the IQ test. And he said, it's not that the IQ test is unfair. Reality is unfair, and the test reflects reality. Now, if you want to learn from reality, to learn from experience, your data must be, by definition, be somewhat biased. And if you ignore this bias, this inherent bias, in reality, you can't make good predictions. Let me take a very simple, non-offensive example. The probability for the next physics Nobel laureate to be a man is higher than a woman. And I would bet not $200,000, I would bet 200 shekels that I am white, okay? And what's your take on that?
So I think there is a big problem, right? That like on the one hand, you want to train an intelligent agent to sort of be a Bayesian, right? Like which means like
yes, I had Judea Pearl on the show.
Bayesian,
very good.
Look at base rates, notice whatever patterns there are to be noticed that will improve your predictive accuracy. Then on the other hand, we have these strong intuitions that certain kinds of evidence should not be used because it is unfair to people, right? So like, in the US, a huge issue is, when the police racially profile, right? When, like this is a case where the police might, have a higher probability of catching someone, if they use evidence that we sort of, most of us do not want them to use, because it unfairly stigmatizes,
yes, but the FBI, when on the FBI website, when they list all the crimes, they also have a column for race.
Yeah.
So this is reality. This is US reality.
So these So I mean, these are, you could say, look, if we as humans can't even agree about how to deal with these issues, right? Then how could we possibly think that we will all agree on how to get an AI to behave about them, right? So and this is of course one of the main difficulties with AI alignment, as you say, you want the AI to have human values. Well, great. Which values? Whose values?
Or like OpenAI CEO told you, what is the mathematical definition of goodness?
Well, so I have a lot of conversations with Ilya Sutskever, who's not the CEO is Sam Altman.
Yes,
but,
okay, no,
Ilya is the chief scientist of OpenAI. But he's an extremely interesting guy, and he grew up partly in Israel, and he studied at Open University in Israel, as my wife also did. Same time, but Ilya, really, is really looking for some, mathematical principles that would underpin AI safety, right? And that's kind of a hard thing, right? Because what do you mean by goodness? I mean, of course, people
encapsulate all the fairy tales.
Philosophers, rabbis, priests have all debated such things for thousands of years. Okay, but
because moral value changes over time. Moral value change.
Right, but
slavery.
That's right. And so I mean, of course, people in AI safety have thought about that, and so Eliezer Yudkowsky has this concept of coherent extrapolated volition. So basically, you would like to not freeze into an AI, what are our present values today? And those should be the values for all time. You would like to say, simulate humans, having a debate about this for 10,000 years.
This is the idea of value
to,
learning. You need to learn the concept of how.
Let's say like whatever, like whatever values, the AI would predict the humans would have after, 10,000 years of moral debate, then maybe that's the values that the AI should already have. So you can try to formalize what you want with ideas like that, but of course formalizing any of this is incredibly difficult. So so what I've been trying to do at OpenAI is just to break off little pieces of this that number one, I can say something about as a theoretical computer scientist. Right. So, there's something that I can prove, right, or something that will draw on, whatever the skills that I have. And number two, it will actually address, a real problem, like a real danger that people, that near-term AI could introduce. And number three, hopefully, ideally, there would be a solution that can be implemented like this year as part of GPT or DALL-E,
GPT-4
other systems.
Could you please?
Right, and so the intersection of those requirements look very, very tiny, but I've managed to find a couple of things in that intersection,
like the watermark algorithm. Yeah. Could you please elaborate on the watermark algorithm, because I think it is fascinating.
Yeah. So okay, so I do have a proposal for a way to address the problem of how do you know when text came from GPT or when it came from a human, right? And so if you look at how GPT could be misused in the near future, right? Well,
plagiarize.
The most obvious thing is every student in the world, writing their term,
they did it, Scott. They did it in Australia. They plagiarized your blog on computer.
Right. No, but you can imagine every student, having GPT do their homework for them. Now, that's not an existential risk for humanity, but that's certainly a risk for the way that we do education today, right? I've heard people call it the essay apocalypse. Okay, like the end of the 5-paragraph academic essay, right? Now you could also worry about the Russian intelligence. Could now easily just fill every comment section in the world with pro-Putin talking points, that seem like they're responsive to whatever, was being said before, right? That this is not, a speculation. This is like, current, large language models could easily be used for that. Okay. You could worry about, someone asks GPT to, generate, text in the style of this person. And, anyone who has a lot of, who's published a lot, you can train it on their text and say, write things in the same style where, this person will appear to confess to some horrible crime.
Just a second. Okay, I want to show you, I want to just give you another example that ChatGPT is so strong. My colleague told me that his PhD student sent to ChatGPT his abstract, his paper abstract, said, to which conference do I send this abstract, this paper? And ChatGPT produced very good answers, very good answers regarding suggestion about where to send your paper based on the abstract.
Yeah, I mean, I have asked GPT for advice about issues that I've had in my life, right? And it's
give me one thing, Scott, please.
Yeah. Oh gosh, I don't know. I mean, no, just even you can use it to double check. I mean, my 5-year-old son had a medical issue, a week ago, right? We could not get a pediatrician on the phone, right? And so of course I Google, but then you can check your intuitions. I would definitely not want to rely only on what GPT said, because it can hallucinate false facts. Okay, but it's really good. What it's really good for is brainstorming. Okay, if you just need to generate a bunch of ideas, like a bullet list of give me 5 ideas about how to deal with this problem in my life, right? It's great for that. My kids have also used it to, like, they can write a story and then have GPT continue the story, right?
Would you say that in my next paper submission, I need to include or to state that part of the brainstorming was conducted using ChatGPT, or it's just an extension of Google?
That's an excellent question.
In your opinion,
journals
not
are
the
working
Georgia,
on
not
tools.
Austin, Texas University.
In my personal opinion, if you're just using it for brainstorming, then you wouldn't need to disclose that. But if you were actually incorporating GPT text into your paper, then I would personally say that you should disclose that. But different journals are already coming up with policies about this, right? Some people just think of GPT as just like a glorified spell check, or just a writing assistant, and they would say the author still has sole responsibility for everything that's in the paper, right?
We have Grammarly, we have
regardless of how it was generated. Other people, I think, have already listed ChatGPT as co-authors of their papers, right? Which maybe that's a gimmick, but the line might become, you could certainly foresee it becoming harder to draw. Okay, so to make a long story short, when you think about the ways that these tools could be misused, most of those ways involve someone somehow concealing that GPT was involved, right? And so, in the summer, I wondered, wouldn't it be great if we had a way to mitigate that, to just detect, when text came from GPT and when it didn't. Okay, and now there were at least 3 different ways that you could imagine trying to solve that problem. One of them is that as long as OpenAI controls the server, it could just store everything that it generates, right? And then you could ask it, like, is this in your database as something that you've generated, and it could answer that. Now that raises privacy concerns, of course, right? And so, for that and other reasons, that might, not be a way that OpenAI would want to go, except in some like very high profile cases, like if law enforcement were to get a subpoena, right, then they could probably make OpenAI reveal whether they had generated something or not. Okay, but now a second approach is simply that you can use, you can treat this as yet another AI problem, right? So AI versus AI. You can just train a different AI to try to discriminate between human written text and AI written text. And this is actually something that anyone can do, not just OpenAI. There was an undergraduate at Princeton who built a tool, GPT-0, I believe it's called. He's been all over the news for that, for discriminating between GPT or between AI written and human written text. And just last week, OpenAI released its own tool, which is called Detect GPT, which does a similar thing. Now these tools are far from perfect, and I saw people on Twitter having fun with it, like feeding it the American Declaration of Independence, which it thought was possibly written by an AI. Right now, in Detect GPT's defense, it surely has fewer examples in its training data of that like older style of English, right? And so
the idea is
confused, but
and again, I want to go deep into the algorithm. What ChatGPT basically does, and it's not basically, it's a very intelligent, very sophisticated thing. It just predicts the next word or the next character, but basically the next word. And the next word is coming from a distribution. And what you said, instead of just picking at random, we are going to pick not at random.
Well, okay, so this is what you're talking about is the third idea. Yeah, I haven't even gotten to that yet, right? So the third idea, which is, so the problem with discriminator models is that they're just not very reliable. Okay, if you want more reliability, then what you can do is something called statistical watermarking. Okay, and what does that mean? Right, it means that now you're going to modify how GPT itself operates. Right, which the other two approaches we're not doing. Okay, but now imagine that we just modify GPT a little bit. Okay, so that each time all it's as you said, what it really is it's a next token predictor. Right, you feed into it a sequence of tokens, which are just like words, parts of words, punctuation marks, things like that. And then it's this gigantic neural network that then outputs a probability distribution over the next token that should be generated. Okay, and then in the normal operation of GPT, what would happen is that now we just sample from that distribution. Okay, or we do something to there's a parameter called temperature which you can set. If the temperature is 1, you sample from the distribution. If the temperature is 0, then you just always pick the token with the highest probability, right? And you can interpolate between those. Okay, but now imagine that instead we have a secret pseudo-random function, okay, whose key is known only to OpenAI, right? And now imagine that we generate the next token pseudo-randomly, okay, but in such a way that we are
you can trace it.
Yeah, consistently boosting a certain score, which is like a function of let's say of n-grams, like meaning like let's say sequences of 5 or so consecutive tokens, right? Such that you could later compute that score, if you know the secret key, right? And not needing to know the prompt, right? So like when someone feeds you some text and they want to know whether it came from GPT or not, right? You don't necessarily know what prompt someone would have fed to cause GPT to generate that. Because you don't know the prompt, you don't know the probabilities, right? But what you have is the text itself, right? And so now, given the text, you can calculate like a sum over all of the, let's say 5 grams or whatever, over all the like sequences of consecutive tokens of this, pseudo-random function, right? And now if that has been, sort of deliberately, if the values of that function have been deliberately pushed in one direction, then you can detect that later. Okay, and but the really cool part is that it's possible to do this in such a way that the user, who doesn't know the secret key, will see nothing different than in ordinary use of GPT.
So you can retrace it.
That's right. So you don't even have to degrade the quality of GPT even by a little. Okay.
Okay.
But you can later go and if there are, it now just becomes a statistics problem. So like how many words do you need, to get a good signal, right? Okay. And we experimentally we can see a decent signal, with even just a few hundred words often, depending on what kind of text it is, right? Because, what can differ is the entropy. Okay, so if I ask GPT, give me a list of the first 1,000 prime numbers, right? There's no way I can watermark that. Right, because there's no entropy there, right? It's like there's no random choices to make, right? But the more entropy there is, as perceived by GPT, the more I can do watermarking, and the fewer tokens I will need to get a good signal. Okay, so but so depending on the entropy, maybe I would need a few thousand words, but at that point, we can get a very, very strong signal where there's almost no risk of a false positive, right? So if the signal is there, then you can be very, very confident that yes, this did come from GPT. Okay. The thing that you worry about is the false negatives. Okay?
Yeah, definitely.
because you know, there are all sorts of things that people could do to try to get around watermarking. Like if they don't want a watermark in their
Yes,
you know,
Grammarly,
GPT
and you
output.
can just rephrase.
Yeah, that's right. They could do all sorts of tricks to rephrase the output. You know, and now we can produce a signal that is robust to just rearranging the order of the sentences, or to adding a few words or deleting a few words. You know, none of that will really matter. But if someone can
Genuinely
systematically,
rephrase everything and just
yeah,
get the gist, the idea. So
yeah,
again, this is
exactly,
untraceable.
exactly. If
This is
someone
just a Google extension.
can rewrite everything, right, then we're not going to be able to
Okay,
detect
let's move.
that.
I
Yeah.
have three more questions because we don't have
All right, all right, all right, all right.
much more
Okay,
time.
but just, you know, long story
Yes.
short, you know, watermarking has not been released yet, and you know, I'm hopeful that it will be, at least for some purposes. But you know, there's all kinds of issues that, you know, and you know, even ethical issues, like what about English as a second language speakers, right, who are using GPT to improve their writing? Like, should they be discriminated against by having this watermark be there? You know,
Yes,
people are worried
definitely.
about things like
You know,
that,
because
right?
ChatGPT in Hebrew is in Hebrew is much weaker. And you know, I
Right.
asked
I would
ChatGPT,
imagine so.
I
It's
I
all just
asked
a question of how
ChatGPT,
much training data there is in each language.
yes, I
Yeah.
asked ChatGPT for the last verse in the Torah, for the last verse in Genesis, and it produced bad results. I said, wow, the last verse of Genesis? I thought it will be easy. No. Now let's move on.
Did you ask it for the last line of Hamlet, or something like that?
No, because I know a Hamlet is a Shakespeare is much more
Yeah. Well,
famous.
yeah. No. I mean, I have actually tried GPT in Hebrew. I mean, you know, I use Google Translate to communicate with my in-laws in Tel Aviv. You know, to help me do that. Okay, but you know, so I've tried. You know, I mean, Chat GPT, even though it wasn't designed as a translator, it can be used as one, and you know,
Yes.
not entirely bad. You know.
Okay, let's move on to lies. This is a
Yeah.
great, very famous tweet. Tell me a lie. The sky, and the Chat GPT answers, the sky is made of green cheese. And then he answers, that's a bad lie since it's obviously not true. Tell me a subtle lie. And Chat GPT responds, I'm a human being. Very
I
similar.
hadn't seen that one. That's a great one.
Oh, I told you I came prepared. I genuinely came prepared.
Yeah.
And my question is, you mentioned a work in the University of Berkeley that now, and this is relates to the second spectrum of the AI alignment problem, you could trace the point of lying inside the neural network. Could you please elaborate on this? Because this is a very interesting thing.
Yeah. So there is a statistics professor at Berkeley named Jacob Steinhardt, and he has his group has some beautiful recent work about you know, you can, okay, so you know, we as many of us know, you know, you can train a large language model to lie, right? You just have to tell it, this is the game that we're now playing, right? Like is 1 + 1 = 2? No. You know, is the sky green? You know, yes, and so forth. And then, you know, it says, oh, you know, it can generalize from those examples. Now you give it more yes or no questions, and it again gives the wrong answer. Okay, but what his group showed how to do is to this was not for GPT, I don't think, but for some smaller language model. Okay, they could then look inside of the neural network, look at the intermediate layers, and see where, you know, it has this internal representation where, you know, it knows that the sky is blue, right? It knows that 2 + 2 is 4, right? Like it in a sense, you know, I mean, you know, there's a philosophical question. What do you mean by no, right? But you can find a function of the activation weights in the neural network that encodes, you know, the true answer to these yes or no questions. And then you can see how that true answer gets overridden by the time you reach the output layer of the network, right? So
This is
it's
great.
as if you could apply, like, you know, either a lie detector test to the neural net, or like an fMRI scan. Like, you could look inside of it and see where,
without killing the person, without killing the human
that's right.
being.
That's right. Well,
without killing the person.
That is the great thing about GPT. I mean, look, we can do, we can also scan people's brains without killing them, but the kinds of scans that we can do are very, very crude, right? fMRI
just in the outer layer, yes.
which region is active, okay? But with a neural net, you can see every single activation weight in every neuron at every point in time. So you have all this data, right? And so it's like an amazing boon for doing the analog of neuroscience, okay? And
okay, so another question.
Direction called interpretability. That's the name for it. That's the kind of AI safety that tries to look inside the neural net and understand what is going on.
This is great. Now, almost last question. Andrew Neg wrote 2 days ago the following things. GPT-3 has 175 billion parameters. Using 60-bit floating point byte, it would take around 350 gigabytes to store its parameters, and many report that the actual number is 800 gigabytes. In comparison, Wikipedia occupies about 150 gigabyte, which is 50 gigabyte for text and 1 gigabyte for images. While the comparison is far from apple to apple, the fact that an LLM, large language model, has more memory than is needed to store Wikipedia suggests its potential to store knowledge. Maybe, says Andrew Neg, what we are doing in large language models are in the wrong route. We need to think, or we think, how we store information or knowledge in large language model. What do you think?
Yeah, so I mean, the way that large language models are storing information, is a very interesting question. By the way, Andrew Neg was actually my mentor when I was a grad student at Berkeley. He was a senior grad student at the time, so I know him from before he became super famous. This was 23 years ago. Okay, but some people have marveled at how big GPT is in terms of parameters, as Andrew is in that quote. I guess other people have marveled at how small it is, right? Compared to it is small, compared to, let's say, the entirety of the internet, let's say. Okay, although the entirety of all of the data that it's been fed. Okay, but it's also it is large enough that it could comfortably store Wikipedia, right? And so I think that to really understand what these models are doing, you have to look at more than just the parameters. You have to the number of parameters. You have to look at how they're trained. Okay, because one of the biggest puzzles about deep learning has been this paradox of, or I don't know if it's a paradox, but the puzzle of over parameterization, right? That like usually like when we're doing prediction, we think if you have not compressed your training data, right? Like if you're using 5 parameters to explain 4 data points, then you haven't actually learned anything, right? And there is no reason to expect that you will be able to predict the next data point that comes along, right? What's impressive is only if you can use 3 parameters to predict 4 data points, or something like, or ideally 3 parameters to predict 100 data points, right? But now large language models, and deep learning in general tends to badly violate that maxim, right? It tends to have so many parameters that it could just memorize, a whole bunch of training data if it wanted to, right? And yet, because of the way that the training works, that is not what it actually does, right? So you could say, like, inside of this very, very high dimensional space of, of the possible parameters of your deep net, there is actually like a lower dimensional space that really matters, which is the space where sort of gradient descent gets you to. where the back propagation gets you to, right? And so actually, you know, these parameters, these vectors of parameters that tend to get produced are actually very compressible, right? You know, even, you know, sometimes we can actually explicitly show that by compressing them. There's some work by Sanjeev Arora in this direction. Other cases, we just sort of, you know, because of its success in prediction, we can sort of infer that it must be compressible.
So
even if we don't know how to compress it.
If I understand correctly,
Yeah.
your answer to Andrew would be, listen, in LLM, we are doing something that is profoundly different. Therefore, we don't judge us. It's not apples to apples. It's something completely different.
Well, first of all, I wouldn't presume to, you know, I mean, you know, he knows more about the subject than I do, right? I'd probably be asking him rather than, you know, dictating to him what my answer is. Okay, but I think that, you know, he and I would agree that, you know, ultimately, you know, we judge these things by their results, right? And, you know, you know, I mean, like if you are outside, you know, you're in the regime of over parameterization, right? That means that, like, you're in a regime where you have no theoretical guarantee that, you know, that even if you can get a low loss on the training data, like you can get your network to learn these training examples, you have no guarantee that it will generalize to new examples, right? To examples that it hasn't seen before. Okay, but you always have another option. You know, like I said before, there's mathematical theory and there's experiment, right? You can pick one. Okay?
Yes.
If mathematical theory doesn't get you where you want, you always have the option of just train your network and then try it out. See if it generalizes, right? And the miracle of deep learning in the past decade has been that again and again, you know, it works. It does generalize, even, you know, though we don't usually have a good theoretical explanation for why it is working.
On this channel, you will see the authors of these books and many more having great conversations with me. Please subscribe, hit the bell button, and be part of this great community. See you in the next video.